All right, welcome back, grade 12s. This material here, combinations, is the bulk of the information you need for this unit, and it is a little more difficult than the previous lesson. Now, if you understood permutations, where order matters, then combinations is the extension of that theory when order does not matter. So let's just get an idea of what we're talking about. In a lot of situations, you do not have to worry about the specific order that things are coming. An example would be pizza. If you order a pizza, it doesn't matter what toppings you order first. Your list of toppings is going to give you the same pizza whether you order the pepperoni first or third, the mushrooms first or third, or second, whatever. The pizza remains the same. So pepperoni, cheese, mushrooms is the same as mushrooms, cheese, pepperoni. And you don't want to double count those. So let's take a couple more examples of situations where order doesn't matter, and hopefully that kind of clarifies that you don't want to double count some of the topics. So suppose you have to do 3 of 5 questions on a test. If you lettered the questions A, B, C, D, and E, the ordered selection of 3 questions, so with order, would be 5, 4, 3. You have 5 options for question 1, 4 for question 2, 3 for question 3, total of 60. That's if order mattered. But at the end of the day, whether you chose A in the first question or the second question or the third question, you still did A, and order really does not matter for a test like that. So how do we account for the fact that order doesn't matter? So here's just a ordered list. So ABC could be coming as ABC or ACB or BAC or C or BCA. Those are all the same. They're all permutations of the exact same test. It does not matter what order you did ABC. As long as you did ABC, that's the type of test. So how can we eliminate all the extra permutations that we do not need? And the method to eliminate is to think of it as yeses and nos. Did you pick A? Yes. Did you pick B? In this case, no. C, yes. D, yes. E, no. So you have 3 yeses and 2 nos. How many total do you have? 5. So 5 factorial, because you have 5 different options, divided by the repeats, 3 and 2. So with the pizza question, again, if you had the pepperoni, mushrooms, and cheese, it does not matter the order. It's all the same pizza. So you don't want to double count. The easy way to do it is to look at the toppings and say either yes or no to the toppings. And then you can figure out from how many toppings you could do a 3-topping pizza from 10 different toppings. It would be 10 factorial because you have 10 different toppings. 10 factorial divided by 3 yeses, so 3 factorial. 7 no's, 7 factorial. And that would give you a 3-topping pizza if you had 10 toppings. All right, let's a couple more examples. Lotto 649. You must select 6 different numbers from 1 to 49. Order does not matter. How many ways can it be done? So again, you have 49 options. So the numerator is 49 factorial. Divided by how many yeses? You need 6. So 6 factorial. And how many no's? Well, in that case, it's 49 minus the 6. So it gives you 43 factorial. 6 yeses, 43 no's, out of a total of 49 total. And that's how you'd solve it. So it would be 49 factorial divided by 6 factorial, 43 factorial. Breaking it down into yeses and no's. So 6 yeses, 43 no's is 49 factorial, 6 factorial, 43 factorial. And this is the shortcut. So instead of using factorials over and over again, we can use what's called a combination. So you use C, 49C6 should be in your calculator. You can be shown or visually you can see it as C, 49 comma 6 or 49 over 6. But either way, it's always in your calculator, 49C6. And make sure you know the combination looks like n factorial divided by, here we go, r factorial bracket n minus r factorial. So there's your factorial notation for combinations. It's a really important slide. Make sure you remember it. So n choose r is n factorial divided by r factorial, n minus r factorial. That will give you combinations when order does not matter. So use P when order matters and C when order does not matter. Standard deck of 52 playing cards consists of 4 suits of 13 cards each. How many different 5-card hands can be formed? So your 5-card hand, it does not matter when you got the card. The order of getting the cards does not matter. So we just need 5 cards from the 52. So 52 C5 or 52 choose 5. How many different 5-card red hands can be formed? If it is a red hand, you only have red cards. Half of them are red. So instead of 52, you've got half of that, or 26. And of the 26, you need 5. So 26 C5. How many different 5-card hands can be formed containing at least 4 black cards? Whenever you see the word at least in this course, it means you're doing an or question. Whenever you see the word or in this course, it's an addition. So you need 4 black cards or 5 black cards.